Hello, calculus fans! Let's find the distance from the point 236 to the plane 2x minus 3y plus 4z equals 7. Now the first thing we should do is note that this point is actually not on the plane. If it was on the plane, the problem would be pretty easy. The distance would be 0. Now the way we can verify that this point is not on the plane, let's just plug in the 236 into the equation. And when we do that, we'll see that it's not satisfied. So if we plug in the 236 into the equation of the plane, we actually see that it doesn't equal 7. So that point is not on the plane. So there is some distance from the point to the plane that's a positive number. We're going to figure out what that is. And what we'll do is we'll describe a general method to find the distance from a point to a plane. So let's let P1, which has coordinates x1, y1, z1, be some given point that's not on the plane. And let's let P0 be the point x0, y0, z0. Let's let that be any point on the plane. And then let's create a vector B, which goes from P0 to P1. Let's take a look at a picture. So we've got the point P0. It's somewhere in the plane. P1 is somewhere up above the plane. And then we've created this vector B, which goes from P0 to P1. I've also drawn a normal vector. And then what we're interested in is the distance, D, that goes from P1 down to the plane. Keep in mind that P0 was chosen arbitrarily in the plane. So the vector P0 to P1, that is the vector B, may or may not be a normal vector. In fact, it probably isn't a normal vector if we just start choosing points P0 randomly in the plane. So we can see from the picture that D, which is the distance that we're interested in, is actually the absolute value of the scalar projection of B onto N. N is a normal vector of the plane. So what we're going to do is we're going to say that D, which is equal to the absolute value of the scalar projection of B onto N, is equal to the absolute value of N dot B over the length of N. Now in our case, the vector N is 2, negative 3, 4. And now we need a point on the plane 2x minus 3y plus 4z equals 7. So how do you find a point on a plane? Let's keep it simple. The point P0, 7 halves, 0, 0 is on the plane. Look, we just need something that when we plug in the x, y, and z values into the equation, it's satisfied. So don't work too hard. Now the point we were given was P1, which is 236. That's a point that's not on the plane. So now let's create the vector B that points from P0, the point in the plane, to the point P1, the point that's not on the plane. And we just subtract the points and we end up with negative 3 halves, 3, 6. Therefore, the distance that we're looking for is the scalar projection of B onto N. We have to put the absolute value in there because we don't know if we're going to get a positive or a negative number. And so that's the absolute value of 2, negative 3, 4. That's a normal vector, dotted with the vector B, which was negative 3 halves, 3, 6, divided by the length of the normal vector. And if you work all that out, then you end up with 12 over the square root of 29. That's the distance that we're interested in, the distance from the point P to the plane. Okay, that's all for now.